Okay, we are live. So welcome everybody to the special edition, the last in the summer of Anglo. Oh, sorry. Sorry. Mhm. Okay, so one more time. Can you hear me? Alex, can you hear me?
I can hear you, yes.
Okay, perfect. Okay, so one more time. Welcome everybody. So today is the day we have the special edition of Angular Online. And today we have four very special guests. And the first in the line is Alex Okrushko. Alex, the stage is yours.
Hey, everybody. Thank you for inviting me, Derek. It was very nice to, perform in front of the NG Poland audience. I really enjoyed the conference last year. Hopefully you will be back to conferences sooner. I will see how it goes. All right. Today, I'll be talking about NgRx component store. And this is the latest edition of, to NgRx family of libraries. A bit about myself. I'm Alex Okrushko. I'm a software engineer at Google, working on the Firebase console. I'm part of the NgRx team, a fantastic team of great people. I'm also organizing. So feel free to join that one as well. It's in the East Coast time zone though, and I'm also very proud to be part of the in-depth dev community that we have. All right, so what's NgRx component store? Well, it appears to be a state management library. You're gonna say, hold on, don't NgRx already have one of these state management libraries, NgRx store? Well, it does, but it's a different kind. And to see what different kind it is, let's first try to understand like what is the state management library? Well, state management is, it's a state and we're trying to manage it. But before we try to understand what we're trying to manage, let's try to understand what the state is. So what is the state? There are multiple ways to split up and this description of what the state is, but I'd like to use this one. Basically, we have a server and we have a web application, right? So on the server side, we have a server backend state, and this is the ultimate source of truth. This is what all our web app persist the state to. This is the truth, and it contains the entire state. On the web app, though, we have a few other states. We have a lot more than these four, but this is the four that I'll mention today. We have a persistent state, URL state, client state, and local UI states. And we'll get into some of them in details right now. So let's start with the persistent state. What is the persistent state? And I'll use a lot of the examples today based on the Firebase console. And this is, for example, authentication that I'm part of and I'm working on as well. So persistent state is the data that is stored on the backend, and we're persisting it back and forth, right? So we're reading it from the backend as well. So this is when we do the API calls, this is the data that comes back. We call it a persistent state. The URL state is the state in our URL, as it probably kind of obvious. Sometimes it's also combined with router state. This is our URL that we add. The next type of state is a client state. It's different, for example, here, which tab is open. So the application knows about it. URL also knows about it, right? We see authentication / providers there. So sign-in method is for the providers. But backend has no idea and doesn't even care, right? We don't persist which tab we have open. So this is client state that stays on the client only. And we also have like local UI state. This is, for example, this enabled button inside has a local UI state. All it knows is it turned on or off. It doesn't know if it's connected to persistent state outside or anything other than that. It basically operates with like inputs and outputs with the container components and stuff like that. And the state of that switch button, it's basically just knows it's very local to that component. Okay, so those are the 4 states, and synchronizing all these states between each other is the most complex tasks on the web application, because we're always trying to synchronize URL state, client state, persistent state, push some of it to the local one, and back to the server. How we do it, like optimistically, pessimistically, and all that. So all of this is what our state management libraries are trying to help us with. Awesome. All right. So how is component state is managing its state and what it is responsible for? All right. Like any other state, we want to read, write, and we want to perform some of the side effects. If you're familiar with the NgRx store, for read we have create selector, so we select things. For write we have reducers that orchestrate how we write the state, how we update and change it. And for the side effects, we have create effect. So that one basically handles all the effect stuff. In the NgRx component store, we also have ability to read the state with a select method. We can write with the updater method, and we can create side effects with the effect method. So you can see some of the parallels there. There are a few other things that component store provides in addition to. I won't be mentioning too much about them. For example, you can also get the state imperatively, which was just recently added, but that's more encouraged to be used in effects and things like that, which we won't be covering today. All right, but let's take a look at the select updater and effect, how they can be used. All right, so first of all, how do we structure component store? Well, component store is responsible for a specific state in the application. It owns that state, and it owns that state in a very specific way. First of all, we'll typically try to describe what state it owns with interface here, like author state. That's like ID, name, book IDs, and status. All right, and so the component store itself, the class, it provides us with all the tools that we can use. So it provides us with those methods, right? Select, update, effect, and others. However, we typically extend it to add a business logic to it. So how we update and use those specific tools. We can first of all initialize our state, either in the constructor directly or we can do it lazily, which I won't be covering today as well. There's a lot of things happening. But basically, there is sometimes, most of the time, initial state. So then how do we select it? We select the state with a select method. And we, take a callback, right? It gives us the state and we specify which property, for example, in this case, we want to get out of it. And we'll push it and it'll be observable of that property as the $sign says. So read-only name is observable of like strings here. So how would we use it in a component? So as you can see, select specifies how, not when. And in the component itself, right, we'll provide this author store in the providers there in the component, and then inject it in the constructor as well. What that means is that this author store is now tied to this component. What it means is that when components gets destroyed, when somebody navigates away from this component, or if case whatever, when this component gets destroyed, our store state is automatically destroyed. So it leaves very temporary. Okay, and now we can access the name by going to the author store, right, and just doing .name$. So this is how we use the selector. So that was the select. This is how we read. How we write. For write, we have an updater function. And again, the updater function itself describes how we change things. For example, given the previous state and status, right? How would it change into the new state? And this one has to be also immutable, pure functions. So if you're familiar with the reducers, this is very much like case statements. And you can have multiple updaters within the same component store. So this is the updater that's responsible for updating the status. And how will we use it? Well, updater status is actually a function. If you look at the bottom there, this update status will pass the loading to it, for example, and this is the status that will push into this updater. And then, so our update status there at the top describes how exactly we will use it. And there's another one at the bottom as well, which is update status loaded, right? So it will update this internal state to load it for this component store. All right, so this is how we write. And the other very critical part is the side effects. And so when people ask me, like, what is a component store? What it actually is? And even in the, when I was writing the design doc for it, the first thing that I say, hey, it's just, a better replacement for your behavior subject, service with a behavior subject, or service with a subject. Basically, you have a service that has some cache, and this is a push-based service. But when people implement their own, service with behavior subject or not, one thing I see very frequently gets overlooked. So for example, in a typical service, if you call the method multiple times, each one will trigger sometimes a HTTP request and do something to it. What people typically overlook is all of the race conditions. This is why I really love the effect in the NgRx global store, and this is why I feel the effects in the component store are super crucial parts. All right, so let's look at how they work. So get author would actually be also a function, but what it takes, again, the how. For example, here it takes ID's observable, and we don't pass observables to it. First of all, it just has this observables. When you have this observables, what we want to do? Well, first of all, when a new ID comes in, we want to update our status, for example, to loading when I'm getting the author. The second thing is the most crucial part is, again, the selection of how we handle race condition. And here, a switch map is an operator of our choice. So if we get the multiple authors at the same time, here we'll just drop whatever we were getting before. So here, switch map will call the author service, get author. And then once we get that author as a result, we'll do another side effect. We'll set this author, this is yet another updater, and we'll also update the status to load it. If we have error, we'll update status to error. And we'll also catch error and basically transform it to empty so we don't collapse this effect. So this is how it's written, get author. How would it be used? How would it be used in a component? Well, it's very easy. For example, in our author component store, we have an input of ID. And we notice author ID is not an observable. It's just a single value. And we call this get author with that single value. However, if there's another ID coming in, well, this get author will be called as well. And if the previous one is still busy, that's where we handle all our race conditions. And this is one big piece that's missing in general in behavior subject, services with behavior subjects. All right, so this was the side effect. Now, how is it different from the global store, right? How is it different? Let's see some of the things that are different and where each one should be used. Well, in NgRx store, as you can know, we have those create selector, create reducer, or create effect. And those are what's very critical. They are all separate files. They are all in separate places. They are split by the responsibility. Selectors are selecting, reducers are handling the changes, effects are handling the side effects. They are all in separate files. What that means is that's very scalable approach. Component store, on the other hand, has to have them all in a single file. And this is also very important to have them in a single file because unlike the NgRx store, the component store owns a specific piece of state, and it describes all the changes and effects that affect that state should be in one place. There are some exceptions for additional selectors, but we won't be covering that today as well. So this is first big difference how things are structured. Also, with regards to the state itself, in the NgRx, the global store, we have a single state, single shared state, and we have multiple reducers that are each responsible for its own slice. So they're not overlapping, but it's a single state. In the NgRx component store, we could have multiple components stores, and they each own their own piece of state, but they're separate, and there could be multiple of them. In NgRx, a component store, ownership of state is super, super important. If one thing that you should take out from this is you should really be careful how you scale your component store. It's not meant for the large scale things. It's meant for a smaller, more localized state. And it comes with a cost as well, right? So NgRx, the global one, the global store has actions, while the component store drops that indirection. So it sort of makes things a little bit easier, right? And more direct. But again, it's very easy to create like multiple levels of stores that are deriving data from each other, restoring, and then syncing the state, making any updates throughout would be a pure nightmare. So definitely there are few tools for you to use. Make sure you choose the correct one. And by the way, NgRx store and NgRx component store can be together in one application. Moreover, NgRx component store could be with any of the global state management libraries like Kita, NGXX, or whatever you want. So it doesn't really, it has no dependency on the global one. It's basically a single file, to be honest, and there's one extra operator. Less interaction, and it's auto-cleaned as well, right? And that comes to the lifetime. So NgRx, the global store basically keeps the state for the lifetime of the application, and the NgRx component store, the lifetime is tied to the containing component. Okay, so now we know like what are the APIs. Where should we actually use the component store then? Well, there are a few examples that we came up with, and where some of them we're still investigating and working with. So basically, take this with a grain of salt, and the best practices for the component stores are kind of early in still development. Moreover, I won't even have time to cover the best practices today, but there are some already. Anyhow, so where should we use it? First of all, it's like a module state. But again, be careful for the module to be small, and I'll get to that in a second. Second one is the shared or common component, and its state. This is what actually led to the birth of this component store. Complex and independent component state. The reactive local UI state with a question mark. I'll get to that in a second. And the provided in root, that one is like even like a warning sign. Please try to not do that. And if you do that, you really have to understand how component store works. All right, so let's start with the module state. So what is the module state? Well, looking back at this Firebase application, we have authentication, we have database, we have storage. All of those tabs open a new page, and those pages in between, they don't share much, right? So they are basically independent kind of modules. They could be even lazy loaded. Yes, they do share some of the inputs, for example, like the project that you're working with, right? That's an input to the state, but within them, they are basically independent. So, so let's look deeper into this authentication module. What does it have? Well, here, for example, I'm in the tab right now where I can select different providers for authentication. I could select email and password, right? So this could be one of the providers. I can use the phone authentication. That's a second provider. I can use the third-party authentications like, Google authentication or even, Twitter authentication. So those are all providers. Those are all separate components, right? When I click on one, they expand just like you see the email and password does. So those are components. Those components don't just live by themselves. They obviously are contained by a larger component. This is identity providers like in a tab. And again, this is super simplified just to get the idea across. So those identity providers also live in, they are in the sign-in tab. So there's also a tab that covers them, providers tab. And that tab has more things down at the bottom, like it has photo, it has like allowed domains and other things. So basically they have that. And we see other tabs are here as well, right, in authentication. We have also like users, we have templates. Those are all, different tabs with their different structures. They have user tables and stuff like that. And all of that, we have like authentication index page that encloses all of that. So how do we get data, persistent data from the backends to these tabs into different components? Well, what we have in Firebase, for example, we have one single API. Well, not single API, but we have an API that gets the data for most of this. So they'll be using a lot of the information, but the API is there. So what we ended up doing is creating the auth-config store. That was self-enclosed. It owns the data for any configurations, and those configurations are then used in all different components. Each one selecting what it needs, each one invoking different effects in the auth-config store when it needs to update something or calling other updaters. So auth-config store, this is super important. It contains this data. This data is not restored anywhere down in the bottom providers or any other components. Auth-config store owns this data. And it's the only one that operates on that data as well. So all updaters and all effects are also on the auth-config store. They all live there. And this is where I should warn a little bit. So module state, when you try to implement the module state scenario, make sure you don't have too many updaters or too many effects, or the state is not too large, because then you have to keep all of them in the same file. That file can grow really fast. Unlike the NgRx global store, which is very well designed for handling large state application. Moreover, by the way, authentication config store is tied to the auth index page, to its lifecycle, but it could have another store, which we, for example, happen to have, was an onboarding store. Onboarding store and auth-config store do not have any state that overlaps. So what it means that your page can actually have a few stores, and some stores can be shared all the way down to children, and some can just stay on top. But the key is they stay there, completely independent. They're not ejecting each other. They're completely separate. All right, so that was the module state. The next one is something that actually triggered the creation of the component store, and it's the shared common component state. Let's take a look at that one. For example, we have an app component, and we have like a few pages. Some of the pages have other components and stuff like that. And then we have a common component. This component could be used in multiple pages, or even at the same page, multiple instances. But so it's a kind of like a dumb component. It talks to the container component with inputs and outputs to get the data in and out of it. But inside that component can have other children, and it could be a very complex component. Sometimes even doing some API calls to the backend using the data that it has. But it's completely independent in a nutshell. So it's self-enclosed. So they can each have their own component stores, not interfering between each other, not pushing this data up. And this was one of the biggest problems that I've been hearing, for example, in NgRx. I've been part of NgRx team for a few years now, I think. Oh, yeah, involved in NgRx for a few years. like, how do I share? I have this multiple instances of complex components at the same time. I don't want to index them in the general store. They have nothing to do with this. So this was the solution, and this is how Component Store was born to begin with. All right. So the third one is kind of like a module state, and module state could be like a special case of this one. But this is, again, the complex independent component state. This is very important. So for example, we have multiple pages, and we have a component A that, again, doesn't share its information anywhere outside. It can only share it with the children component B, C, and D, for example. So it has a component that's tied to its lifecycle, and the rest of the components basically inject it as well and select the information that they need from that component. So it's kind of like a module state. It's module state more of like a special case of this one. The next one, I put the question mark, reactive local UI state. This is a very interesting case. For example, we saw that enable button, right? Was it on or off? Typically, right now you just save it as a variable, it's like enable, and it's a Boolean, whatever, or is enabled as a Boolean. And that works fine, and that even works with on push, because most likely interacting with it will trigger change detection and all that stuff. So it works nicely. However, once you start moving into more like a zoneless direction, then it would basically break. So you need some pipes that will trigger the change detection, and that means you need to make the local state also reactive. So this is a special case. I don't have any examples of it, but this is mostly for the zoneless applications. If you're into experimenting with that, then it's also a great solution for this. And the last one is provided in root. This one I would be very cautious about. First of all, as we see, the component store was mostly designed to be tied to one of the nodes in our application tree. Provided in root means it's singleton, it's available throughout. If there is a state that needs to be shared out wide, but it's very limited, it's not interacting with anything else, maybe, but for me, I would try to stay away from it as much as possible. Moreover, think of global state in NgRx. That's designed for global state. It's designed for shared things. And for example, like in a component store, right now, you cannot dispatch an action that triggers multiple things. You call a thing specifically, you call an effect, and that effect does some updaters and does some calls and all of that. So in that sense, NgRx global state is definitely more suitable tool. But again, from NgRx team, we decided to give all the tools available for you and trying to explain and warn some of the good and bad usages. I'll also be doing some of the best practices sometime later at some other meetup, maybe here too. But I'm also working on that. There have been a lot of interesting things that we came up with already based on our experience with the component store. So stay tuned for that. One thing I wanted to say is that I wanted to thank these people a lot. First of all, Kevin Elko, he is my teammate at Firebase. He was the one who internally started Component Store like a long time ago. And basically that's how NgRx Component Store, was created to begin with. Also, Brennan and Tim they're on my NgRx teammates. They provided a lot of feedback, constant reviews. Many thanks to them for being very responsive and providing great insights. And Nicholas Jameson was also fantastic. A lot of interesting ideas I was bouncing off him just to see how things work. So he was very crucial in helping with it as well. Last thing I want to say is NgRx.io has a component store docs. Those are just starting. I have another one coming, another bunch of docs that will be added soon. So stay tuned to that. That's where I also try to share some of the best practices, some of the usages, and all of that. On that, I'd like to thank you so much. And we won't be taking questions right now, but I can look through the chat to answer some of the questions. And also, we'll be having Q&A at the end. Thank you so much. Derek, back to you.
Yeah. Okay. So, Alex, thank you so much for this great presentation. A lot of valuable information. So, yeah, it was just awesome. Um, thank you. And next in line is Erlian. Erlian, can you hear me?
Yeah, I can hear you.
Okay.
Actually, I have so many questions to Alex, so I don't know if I should ask or
Yeah.
not,
So,
man.
if anyone have any questions, yeah, just use the YouTube chat, or we can have some short Q&A session after the meetup. Yeah.
Amazing.
Okay, Ariane,
So
one more
let
time. The
me.
stage is yours.
Can you see my screen?
Yes. Yes.
Okay, let me share it. Amazing.
Perfect.
Now I have just the bar with the images. How can I get rid of it? Never mind. So, hey everyone, my talk today is about a scenario I see many developers struggling with, and I call it creating a functional component or custom component templates. Is it very often when you need to create a functional component that's doing one thing, but then you start to expand it to support more and more template features. Where's the mistake? Lots of developers will expand their components using more and more inputs, and then adjust their component templates using ngIf instead of just letting their consumers controlling the template. About myself, I'm Eliran. I'm the founder of eSquare.io, which is the leading front-end consulting in Israel. I'm a Google developer expert in Angular, a part of Angular in Depth community, and a community leader in the Israeli scene. Our story for today. Imagine the following scenario. You just nominated to be the developer who's in charge of a huge organization UI library, and every component you're going to create is going to use by more than one team. Now, you have just been asked to create a new image swiper component. The requirements: it should get images sources as an input, should support trackpad swiping, and also should have next and previous buttons to control the navigations of slides. The end result should look something like that. If I'm swiping my two hands, so it's going to go to the next one, and I also have two buttons, next and previous. Now, if you know me, you know that probably each of my talks have to have some sessions of live coding. So we're going to close the slides and let's create this swiper. Now I have to take this down. Let's start. So I will start with creating the swiper component. Let's go to our swiper. By the way, I have just a setup of an Angular CLI new project. I will increase the font a little bit. I hope you can see it. Okay. And let's start with creating the swiper. Now I create the swiper wrapper. Here I will create the slider itself, and inside of it I will create these slides. Slides I will iterate with ng4. And you know what, before that, let's create the input with the slides. We know that it's going to be a string array. And we know also that we're going to have a function which is going to call slide that's going to get the direction. It's going to be the number. And let's wire this thing up. So ng4 let slide of slides. And inside the slides, let's just bind to the image source and show the slide. Let's also add the buttons. So I'm going to create a button, one for moving next, and on click, let's wire it up to the slide method with +1. Next, and also let's create a prev for previous, which is going to call the slide -1 and previous. So in order to create the swiper, I need to add some CSS. Let's take our swiper, set it to position relative. Now the slider should display flags and overflow X scroll. And the trick here is actually use scroll snap type property with X mandatory. Now, each and every slide we will set the mean width to be 100 of the viewport, of the width viewport. Also, we're going to set it the height to 500 pixels. We can just centerize it with flex center, and justify content center and align item center. And also snap scroll align will be stopped. That's it for the slider. Now just let's also support the controllers buttons. So we'll create the button. It's going to be a position absolute with top of 250 pixels. So it's going to be a little bit in the center. Now let's say that the next button is going to be right 30 pixels, and the prev will be in left 30 pixels. That's it. We have the basic implementation of the swiper. Now let's just implement the slide method. Okay, when somebody click on the slide, what's going to happen? So first we have to just save all the slides positions. So we'll create an array slides positions, which is going to be an array of numbers. Let's also create a private method called get slides positions. I will add a constructor here and inject the document reference, private document, document type document. And now when I have the document, I can take the slides positions and using the document to populate them. Okay, how I'm going to do it? I'm going to first initiate this slide position to an empty array. And now I can use the document query selector all to get all these slide div elements. I'm going to iterate for each of them, yet the div, which I know that is going to be an HTML element, and then just push it to the slide positions. So I'm going to push the div offset left. Let's take it down a little bit. Great. Now I'm also going to implement the after view init lifecycle. When I have the ng after view init, I know that I wanna call the get slides position in order to populate the slides positions. Now, when I have the slides positioned, I can actually implement the slides method. So we know that if somebody clicked next, we're going to add +1 to the current index. And if somebody clicked the previous, we're going to do -1. So let's also save the current index. Let's set it to 0 in the beginning. And now the slides position is going to be the direction plus equal to direction. Here we have to check two things. We have to check that we are in bounds. So I'm checking if the current index is greater than the slides position length -1. I know that I need to be in the first one. So I'm just setting the current index to 0. And same goes to the other side. If the current index is less than 0, so I'm setting the current index to slides position length -1. Great. Now that we have done that, we can just call the scroll to create the slide effect. So I'm going to use the document again, where I select my slider. And here I'm going to call scroll to left to the slides position in the current index. And let's also set the behavior to smooth. So it's going to look like we're going to have a smooth effect. Now let's check it out. So we have the basic setup. Let's now release the component to the first consumer. So the first consumer is first, I have here some data array of images. Let's create a slides property inside consumer1 component, and it's going to take the image list. I have some prepared array with images. Let's just filter them so I get only the image, map them so I get only the image URLs. Now, let's create the app swiper and set the slides. I wish I had autocomplete slides to these slides. Let's check it out. And now consumer1. Hopefully something should happen. I have console error. No. All right. So here I have the swiper. When I'm taking my two hands and swipe to the right, that's what I'm getting. I'm getting a nice behavior that just show me images. And if I'm clicking on the next button, I'm getting the same behavior of the swiper. If I'm getting out of bounds, so I'm getting to the first one. If I will click previous one on the first one, I will get to the last one. Pretty nice. Now let's go back to our slides for a second. And let's say, where is my slides? No. Things get complicated a little bit. Now, as we said, I'm a UI engineer that's serving more than one team. Now, consumer2, which is team 2, really likes my swiper, but he wants to use it not only for images. Let's say you just want to show the speakers' names, this event speakers' names, or just screens, or whatever he wants. And he also wants to control the navigation by his custom events. So I need to expose the navigation somehow so consumer2 can use it. Now, as I know consumer2, UI requirements will probably keep coming. So let's rethink. How can I solve it? First, the first thing come to my mind is to add some inputs. Let's check if I'm passing a string of image list, or if I'm passing a string of just strings, string array of strings. So I can check with ngIfs and add another input, but then I'm going to ruin my neat component, which is functional. My functional component is just to swipe full slides and not support many templates. What can I do? What if we can give our component consumers full control over the templates? Let's check it out. And that's exactly what we're going to do. So I'm going to turn off the, wait. Okay, I'm going to turn off again the slides and let's go to the code again. So instead of just passing the slides, let's add another input and call it template or custom template. Custom template, and it's going to be of type template ref, which is a generic, so I will just use n at the moment. Now, I don't want to break the consumer one usability already, so I'm going just to wrap the original functionality of this component with an ng template, and I will call it a default template. Now, how can I show an ng template? I will use an ng container and use the ng template outlet. And inside of the ng template outlet, I will say, hey, if I got a custom template, use my custom template, but otherwise use the default template. And with that, we didn't break anything for consumer one. Now, we want to support the extra parameter that consumer two want to use. So we also need to pass the slides itself, the slide reference to be exact. How are we going to do that? We have another property in ng container, another input called ng template outlet context. Here I can pass an object. Inside this object, I can expose any reference that I want to any consumer. So I'm going to use the dollar implicit, and we get to understand what is the dollar implicit in a second. I'm going to use the dollar implicit to expose this slide. Now let's go to consumer two, and let's say that consumer two is sets the slides to be a string of the speakers list: Alex, Eliran, Fabian, and I don't remember the last one. I'm so sorry. Never mind. Alex, Eliran, and Fabian. Okay? And here, I'm going to use the same app swiper, pass the slides, as I did before. But now, instead of just use the default template, let's also create an ng template. And I call it my template. I will give it a local variable called my template. Inside my template, I want to get the slide reference. How can I get the slide reference? By using the let directive. And let's say I'm calling it let name. I can use whatever I want. And if I'm not passing anything after the equal sign, I will fall back to the dollar implicit one. We will see that in a second when we create the navigation reference. But for now, let's use the let name. Now, let's say that I just want to print the name, but maybe add a prefix of speaker's name is name. And now, as we know, we're passing also the next argument, the second argument, which is the custom template. And the custom template is equal to my template that I just created over here. I can make whatever CSS changes that I want inside my template. And when I go to my functional component to consumer two, wait a second, let's make sure that it's the latest one. Yeah. Speaker name is Alex. And when I swipe to the right, I will get speaker name is Eliran. and speaker name is Fabian. And of course, also the controller is work out of the box. I kept my functionality component and gave others the ability to use it, not only for images. Now, as we remember, consumer 2 also want to control the navigation by himself. How are we going to give him the ability to control the navigation? Let's create a nav object inside our swiper component. And here, I'm going to expose two functions. Let's expose prev, which will be an anonymous function that's going to call this slide with -1, as we know. And also next, it's going to call this slide +1. Now we want to expose this nav object. How we can do it? The ngTemplate outlet context. I'm just adding another one, another property to this object. Instead, just pass the $implicit. Let's also expose a property called navigation. And navigation will be equal to our nav object. Now, if somebody wants to use our navigation, let's say that consumer 2, I will go to consumer 2. And now I can just add another let directive, call it whatever name that I want. Let's say my nav. And my nav can be equal to navigation. Now, I will create a button here that on click will use my nav dot next. I will invoke the next function, and inside I will just use whatever text that I want to move to the next one. Click here to move to the next speaker, for example. Let's give it a second to recompile. And now, when I still have this swiping with ends ability, but when I'm clicking on the button, it's also moving to the next one, as expected. And with that, I actually gave my consumers full control over my functional component with just exposing some properties from my swiper. Well, let's go back to our slides. Or I wish. Wait a second. There are my slides. Okay. So let's summarize what we just saw. Using ngTemplate outlet can give our components consumers full control over the template without adding redundant input or ngIf. We can use ngTemplate outlet context to expose any inner component functionality. And if you're building a UI library, if you're using Storybook, if you're doing such things, and you build something that you're sure that will be expanded, just use it almost everywhere. It's will give your component consumers much flexibility over the templates. Before we go, good opportunity to say thank you to the conference, to the meetup organizer, Darius. Thank you very much for having me. I will be available on eSquare.io if you have any questions, and you can reach out to me. I will stay for the Q&A session, of course. You can start popping out some questions, and you can hit me on Twitter or any other social media that you want. The slides, repo, and everything else will be available on my website, eliassi.dev, and you can find there almost every talk that I gave before. And that's it.
Okay, thank you so much, Alirian.
Thank you.
Great presentation. So one more time, thank you so much. And next in line is Fabian. Fabian, can you hear us?
Yes, I can hear you. Can you hear me?
Yes, yes.
Perfect. So can you see my screen?
Yes, everything works perfect.
Perfect. Thank you very much. I think we give it a go.
Yeah.
All right. So, yeah, welcome folks to the third talk today. I'm very honored to be here. I'm very, very excited, to be honest. This is kind of my third or fourth talk, which I'm giving online, which is pretty confusing situation, talking to like a webcam and imagining or picturing people listen to you, but you don't see them basically. But yeah, welcome to my talk, Architecting Angular Apps with Libraries. Before we start, my name is Fabian. Hi. I'm a Microsoft MVP, a Pluralsight author, and I'm also Google Developer Expert for Angular and web technologies. So if you have any questions concerning this programs, what we do is something like that, just hit me up after the talk. I totally I'm willing to give you information about that. So I was asked to get my talk about like 20 to 40 minutes. So I think in the next 30 minutes, we will talk about architecting Angular apps with libraries. When I'm looking into bigger applications at customer side, I'm always thinking maybe this part of code is kind of a candidate for a library and can be like sorted out. But before we start into how we can create libraries, what they are good for, and what we can do to maintain and publish good libraries, we will start with the why. Why should we do libraries, you know? So when we start our Angular application, basically when we started, you have all seen like your normal component, right? You're just starting off with one component and you're just picturing it and you're hacking down your code in there. And then your application grows and it grows, you know, and then there's another component which you have to maintain, and there is another component which you have to maintain, and so on and so forth. So we have like growing applications. And the application grows further and further, the more features you add, basically. And sometimes you come to the point, or you will get to a point, where you just sort some functionality and some code out into a service, basically. And you wrap that whole thing in the module, the app module normally when you start, but your application grows and it grows, and you're adding another module with another component. And maybe you want to use that logic, which is based on that service, which you have like in the other module, and you wanted to use in the other module as well. In the second module you just added, which is like a new feature basically. So what we can do now is we can create another module or folder based on the syntax you're using, and we can place that service into this, right? So we have like a point of the lowest common denominator, and then we can share that functionality, that service from there. And this can be done when you are inside one application. So this is pretty fine. You can share functionality into different modules and different components, and you just abstracted them and extracted them into a service. So all fine until there. And then you're hacking down your application, and then your colleague comes to you and tells you, hey boy, there was this nice logging library you had. Like, I want to use that as well. And you're like, yeah, that's living in my app. Basically, I extracted a service, you know. And he was like, is there any functionality or is there any possibility that I can use that information or that functionality in my application, which is also like modules and services? And maybe you want to share something from app 2 to app 1 or something, right? And this is exactly where libraries come into play. So what we can do now is we can go one step back and not extracting code into services directly, but we can take that services and place them completely out of our application inside of a third party of a library. And then we can include from that library like modules, services, or whatever we want to, and use that functionality. And we have it like on one spot. Right, so basically this is why we should do Angular libraries. They're a good thing to architecture your application, right? Because you have code which is reusable. So one of the reasons you do it is the reusability, which we have just seen. So you have like the code in one spot, and then you can reuse it over the borders of one application. The second reason is it's don't repeat yourself, right? You're just writing the code once and you're just maintaining it at one place. You don't have to copy and paste it over and over and over again. We will refer to that slide later on at the end of the talk, basically. Another good reason is testing, right? So you can test the functionality you have inside of that library. You can test it. It should do what it should do. Basically, it should do it good, and you can test only that functionality. And when you have like a bug in your application, you can be like more sure that the bug does not come from that library because it's basically tested, maybe battle-proofed in some other applications. And so it's working pretty well. So you have extracted it. What else is our libraries good for? They are good for the complexity of your application. So from the application point of view, it reduces the complexity because you're like getting rid of code. There is less files you have to maintain inside of your application. So if you take in the view from the developer, which is developing your app, right, it reduces the complexity. If you are like an Angular architect over like several or multiple applications and you're just maintaining multiple libraries, it adds complexity in another way, because there's like in the system overview you have, there's like one bubble more, which you have to have on the screen, which you have to have in mind. Okay, there's another spot which I have to know, okay, it is there. So if another developer wants to add like logging or authentication or something, we have that library, right? So it reduces the complexity from the app point of view, but it adds some kind of complexity when you're looking at your complete system, when you're maintaining multiple apps and libraries, like hundreds or I don't know. So if you want to write a good Angular library, what are the requirements for a good Angular library? And I'm referring to a blog which Minko Gechev wrote in 2017. There is basically a good story about NG Poland, where I've been in 2019, and Minko Gechev, because he was spilling like a glass of orange juice all over my laptop right before I wanted to go on stage. So every time I see that slide or I'm seeing Minko's picture, I have to think about that. But this is not about any spilling orange juice over laptops. This is about the requirements of a library. So Minko wrote a good blog post about this. You can find the link underneath. And he said a library should be platform independent, right? And this is a very interesting point, because when you're writing Angular library, you have to keep in mind that Angular is platform agnostic, right? So you shouldn't touch the DOM to be concrete when you're writing a library. We have abstractions for this, right? Angular provides you abstractions for this, like the renderer, and so the DOM and everything you have to interact with gets abstracted, because if you just access it directly, it would be like unable to work within web workers or on server. Maybe some developers need that. So keep that in mind when you're writing libraries, that maybe you do not have a DOM for the consumer when he uses your library. Of course, it should be bundled. Sure, I don't want to deal with all the files you give me as an architect. I want to have like a bundled version of your complete library, and it should be AOT compatible. Of course, it should be ahead of time compiled when you deliver it, and it should be compatible that my application can use it with ahead of time compilation. And I think that's pretty common. It should use TypeScript, right? So use TypeScript. You have the complete types which you can like provide to the consumer, and he knows, okay, when I get this object, it's from this and that type and stuff. So this is pretty neat when you're working with external sources and they provide you typings. And just to get that all under like one cover, just to write that down, the Angular team sat down and created a kind of format just to tackle all that bits, and providing you like a way to go to write Angular libraries. And this is the Angular package format, right? So the Angular package format is like a recommended way to distribute Angular packages. It just describes a file and metadata structure and says what has to be placed where and what should be in it, right? It supports various formats as an output, and it's also the format of the Angular core packages, right? So right now we have the Angular package format in version 10. This is a screenshot from version 8, but basically it looks the same. It's just a not that big document. You can read it through. It's really, really interesting. And I would really, really recommend you to read through this. So really, really interesting information in that. I learned a lot when I read it. However, when you really want to write a library, what are the steps which have to be done to get through like the output, which is basically can be used from your consumers, right? So the first one, or the first step which has to be done is like to inline all the templates, which makes it easier for the compiler just to go through it and tree shake it and ahead of time compile it, right? So then you have to just pull the whole thing to the NGC, to the Angular compiler. And then what you should do is spit out ESM 2015, ESM5, and UMD. Right? So these are various formats, module formats from JavaScript, basically. And ESM 2015 is like the pure ECMAScript 6, which we all know, which we are going to use in our everyday life if you're a JavaScript developer. ESM5 is like a hybrid format. So ESM5 is like ES5, so ECMAScript 5 JavaScript, but with the import and export statements, which are coming from ES6, basically. So it's like a hybrid format, and it is just described as ECMAScript module 5. And then we have UMD, which is basically the universal module definition. Back in the days, we have done this. So the AMD and CommonJS is basically combined under the universal module definition, the AMD asynchronous module definition, and CommonJS as another module format. Right? So these are pretty common, and you as an Angular library should spit out everything. So this is how the Angular format looks like when you're building it. So you have like a ESM5, ESM 2015 folder, you have a library folder, but you also have this FESM5 and FESM 2015 folder, and the F stands for flat. So you have like the flat version of it, which is basically just one file. But all of these files you see here, you don't have to create them by yourself. And you don't have to, when you want to compile it, also putting the output, you don't have to do that all by yourself, like getting it through the compiler and inlining all the templates and stuff. So there's a project which is baked into the Angular CLI, which is called the NgPackager, right? And the NgPackager basically bundles it for you. It creates the type definitions for you. It does the inlining for you from the template and the styles, of course, and all the stuff like that. So this makes your life pretty easy, and it's baked in the Angular CLI. What it basically does is take in the library files, like the public API, which is getting created. We will refer to that file later on. It will take your TS files and the package JSON. It will go through the NgPackager, and it will spit out all the Angular package format files, which we have just seen, right? Of course, the NgPackage can also be, or the NgPackager can also be configured. What you point to with your library is to an entry file, which is public-api.ts. And you, of course, you can, or you have to give him a destination where to put like the Angular package format when he compiles it, just where he spits out the files on your local file system, right? And then the public API.ts is basically like an entry point to your Angular library. So what you export from there can be like imported in your app. And this is basically when you start with a library and you let it generate it over the Angular CLI. This service component and module just get exported from default. So this is basically a screenshot from the public API file. And then you have like one point where you can refer to, right? So you wouldn't import from mylib/source/classes/ or components, I don't know what. So you always refer to that my-lib, which is like a path which points to the public API file. This is pretty important. And of course, you can also import multiple things, which are multiple types, which are getting exported. And I have seen that there's a lot of confusion about this public API file out there in the wild. So I would like to dedicate a small part of this presentation to understand basically the public API and to do a small differentiation between ECMAScript 6 modules and Ng modules, because that is what's basically behind that whole thing. So let's take a step back and look at a normal application we do. No library involved. This is just a normal application. Like we have a component, which is called myComponent, and we have a class, which is called XYZ module. It declares the myComponent. Then we have another module, which is called the app module, and we're just importing that module from a specific folder, right? And then we would like to use the myComponent. So in this scenario right here, this wouldn't be possible. We couldn't use the myComponent. Why? Because it doesn't get exported from the myComponent in the ng module decorator, right? We have to add it to the exports array. And normally everything is private inside a module. It's like a black box. And when you export it specifically with the imports array, we are importing everything the module exports, which we've just done. And then we can use the myComponent. So let's put the my component and the XYZ module inside of a library. And now we're importing the XYZ module from that specific library, right? So then with the lib, we're referring to a file which is called public API, and it exports everything from the XYZ module, right? And now we can use that component again, which is totally valid because the module exports the my component as well, right? So what if we would like import the XYZ module and the my component from that lib inside our app module, which makes no sense in that scenario. But what if we would like to import the type of the my component, right? So this wouldn't be possible. Why? Because the type doesn't get exported. It only gets exported what from the ng module, and then I import everything what the ng module exports. But the type of the my component doesn't get exported. So I couldn't import it with the ECMAScript 6 statement. So I have to export it explicitly, and then I could like import the my component and do anything else with it, right? So this would totally be possible. Let's take a look at services. If you're using services inside of a library and you want to provide them and you're using the providers array on that module, again, we are exporting everything from that XYZ module in our public API. Then we import the XYZ module from that lib. And when we import the module, the providers are normally getting merged, right? So the type is basically known for the Angular dependency injection. But we can't import the my service from lib because the type itself isn't known, right? So Angular knows about it, but the type isn't known. TypeScript doesn't know what to deal with it, or it looks at the library and tells you, hey, there's nothing I can really import. So you have to export the type of the my service again, and then you can import the my service from that library, and then you can work with it, and you have all these IntelliSense, which we all love from TypeScript. If you're using the provided in root, basically, you don't have to import that module for it. You just can import the my service from that lib. But again, as you import the my service from that lib, you have to export the type explicitly, and then TypeScript can really resolve it and can work with all the types, basically. So as a rule of thumb, you can take away that if you import from a library via ECMAScript 6 import statement, it must be part of the entry file, the public API file, and then you can basically use it and you're good to go. If you're working with the Angular CLI, you know all the ng commands, right? So you can generate a library from scratch and just type ng generate library and then my-lib, and the Angular CLI will scaffold everything for you. And here I have a screenshot which is coming out. It should be like sort of that. It didn't change much in the past. So you have a lib folder, a my lib folder, you have a source, you have a lib, which is just containing a component with its tests. It's got that module we just spoke of, and then it's got service, it's got that public API file, which is pretty important. Then we have all the tests, comma, setting up, and all the configuration files for it, right? So this is pretty neat. And you can go further. You can say, okay, I just want to build my library with ng build and then my lib. Right? So you have extracted something inside of that library, and then you build it, and then you can basically use it, right? You can also put a watcher on it. This helps a lot when you're just working on that library and just save a file, and then it gets automatically rebuilt, and you can use the latest files inside of your application, and then you have the latest sense and can work with it. From developer to developer, it hangs sometimes. So sometimes you have to like just cancel it and rebuild it, and then it should work basically. And the outcome of that is, like we have just seen, the bundles ESM5 folder. This is the Angular package format. This is what you find inside your distribution then. And this is what basically you can work with. But building and testing is not the only thing which we can do. We can also lint that whole thing, right? So you can do an ng-lint mylib, and then it will run the lint command over just that particular lib, and you can ensure that everything works well. This is very important if you're working on your own, on your library, when you're just doing your workspace and doing your stuff. I'm talking about app libraries, which we'll get to later. But when you're doing an open source library or something, this becomes even more important because you have to have one code style and it has to be linted and stuff like that. So you can do that as a hook or something like that. So that ensures that all the linting rules are getting applied. You can also test that specific lib with the ng-test command. So basically all that ng commands which are running for an app are also valid for a normal lib, which you can do. You can also put the watcher to false, of course, if you're running in a continuous integration, continuous delivery environment. So you put the watch to false, and then it doesn't get like when you save a file, the tests are not getting re-triggered and just pop up, and the process of testing ends then if something good or bad comes out, it's even a 0 or it's a 1. I just talked about libraries which you're doing internally for yourself, or libraries which are published to the outside world through npm, and this is where I want to get to next. But before we get to that, I want to lose a few words about the quality of your code. I'm not talking about how you basically should code and what your syntax is. I'm just talking about keeping the quality and at a stand you introduce. And if you have maintainers, this could be inside your company or it could be outside your company, just keeping that quality, and you don't have a mess when you're working with. This applies to apps as well, but if you're working with libraries, this is even more important. So I would recommend something which is called Prettier. I don't know if you use it, you should basically. It's really, really a good tool, which is just like reformatting your code, and you can introduce it to your Visual Studio Code or WebStorm or whatever, that when you save, it gets reformatted. So I just got a little bit of code here, and I think Alex will be really, really proud because I'm using NgRx. And you see that I'm just formatting something here, and when I save that whole thing, it just pops back and everything is like the rules basically tell me to do. So if you have multiple maintainers, when you publish something, when you outsource something in a library, this is pretty important, right? Another thing which I want to introduce is Husky, right? Husky is a pretty neat tool if you want to introduce Git hooks to your applications. So if somebody can't like apply all the Prettier rules when he saves in his environment because he uses some kind of environment which just has not that enabled, it's totally up to them. And you can just add a Git hook, right? You can find that under typicode, github.com/typicode/husky, and then you can see how it's being configured and stuff. And what you can do with Husky is you can do some pre-commit hooks or pre-push hooks. So every time before you commit or before you push, you can define several rules which have to be run through because otherwise they can't push. And this could be like a place for your testing and for your prettier things and stuff like that. So when you go out with your library, consider that, because you want the people to engage and you want the people to submit pull requests and look at that code and find bugs or fix bugs, basically. What you also can do is, I was talking about linting a few minutes ago. You can only lint the staged files, which is pretty neat because sometimes you have like a big library and you only want to lint the staged files which are staged in that git commit. Then there is a package as well, and it's called lint stage. And when you're letting run that, it will only lint the staged files, which is like much shorter than linting every file, even though even these files you don't have touched basically in your commit, right? When you want to use the library, it's pretty common to throw that whole thing on npm. So npm, the Node Package Manager, is one of the platforms to distribute Angular libraries or JavaScript libraries or Node programs and stuff. So you could easily put it on there, right? But before you do, I would recommend you to test locally if it really works and does what you want to do. And of course, you did all that testing stuff and all that kind of things. This is pretty fine, but I would recommend you test it locally before you're going to publish it, even on a like internal npm server at your company, maybe, because you don't know how that thing behaves in the wild, and you should have tested it, right? Tested it under a normal program. So what you can do, you can in npm install from a specific folder. So what you can do, you can just run another sample app and just npm install and point to that folder where the Angular package format lives with the package.json. And then you just npm just installed it from that, and then you can use all the functionality, which is pretty neat. It also gets added to the package.json, and then it behaves like it would be published, but locally on your side without any npm server or without any server at all. You just have to install it from that particular path. You can also link it with the npm link command, right? So you npm link from that specific folder. This won't touch your package.json. I found, again, link a little bit of, it was shaky. It wasn't reflecting all my latest changes. But yeah, you have to drive with what you want to, basically. But what I personally like the most is when I just hop into the dist folder where I just build my library, and I'm running the npm pack command. And the npm pack command is generating like a zip version of what gets distributed to npm if you would publish it, right? So you can npm install the package.tgz afterwards, like npm install to the pass, but the tgz then, and this is the closest as you can get to the version which gets distributed to npm if you would publish it, right? So this is a pretty nice feature, which I think I'm using that all the time if I want to test locally if my library does what it should do, basically. Another thing which you should know about is Verdaccio. Verdaccio is like a local NPM server. So you can just run it up locally, and then you have to, you can like NPM install it like normally, but you just have to point to that Verdaccio server, which runs locally on your computer. And then it behaves like a normal NPM server, which is also pretty cool of testing. Here is a package, or here's like the UI. It comes with everything with the UI, and you can just upload packages and download or install them as you want to, like with a normal NPM server, which is pretty neat as well. And when you do your library and you have all that like services in it and components in it, you can deploy your lib. Like I just said, to npm, which just takes like a few steps. But you should pay attention to a few properties there. So you can configure your library, and I want to just point to two particular properties. One is the version, and you should follow the semantic versioning because people rely on that, you know, because when I see an NPM package, I really look which version number changed, and can I just install it without expecting any trouble, you know. And it goes with a major minor patch. So every time you patch something, you just do like the last number. If you have like new features or something, you can increase the minor number, and the major number is if it's like breaking changes, right? You start with a 100, and then you can do a 101 with the npm version patch command. So npm can bump that version for you automatically. Then you have like the 110 when the npm version minor command, and when you want to raise like the major version, you can just run the npm version major, and then it should be fine, basically. I'm just paying attention to what number you increase, because really people are really looking at it and expecting trouble or not, depending on your version number which you increase. The second thing I want to refer to is the name. So most likely, if you publish a library, and in my case, this was like an Angular rating library, which was just rating stars, which you can hover with your mouse, and then it was like filled stars or not filled stars from 1 to 5. The Angular rating was like covered already, so this name was taken. But when you publish something to npm, you always have your username as a scope. So in my case, this would be @Fabian Gosebrink /Angular rating, and nobody can take that away from you, because that's your scope, and you can just deploy packages under this the username with the @ in front, and then you can just distribute the packages as you want to, right? And distributing a package over npm is really easy. So everything you have to do is log into npm, right? And then you add a README file, and then you bump the version to the right spots and the name, as we have just seen, and then you hit npm publish, like the command npm publish on your command line, and it will just be published to npm. And like in a second, it's online and other people can use it, right? And before you do that, and if you take one slide away from that talk, let it be the next slide, basically, because be sure to remove all sensitive information before publishing, right? So all credit card informations, if you have any files on it, any photos which you do not want anybody to see, like passwords, tokens, hashes, or something like that, just remove it, right? Just double check it, and be sure you don't upload this to npm, because it gets really easy. And yeah, in a matter of seconds, it's just online, and then you have to see to get that information out again, basically, when you don't check it in front. So one thing I would like to point to is like the Angular CLI workspaces, because you don't have to do an ng-new, and it will create you an app in the first place. What you also can do is you can create Angular workspaces, and the workspaces has initially no app and no library registered, right? And this is, if I would start a new project at a customer, something I would always start with an empty workspace, and then adding an application or more applications or more libraries, or one or more libraries to it, which makes it pretty easy because they are like summarized under that projects folder there, which you do not have when you do like a normal ng-new without doing a workspace. And you can do a workspace if you do ng-new demo repo and then the create application equals false flag, and this will create a projects folder for you, and then you can cd into that thing and do ng generate app, and then your app basically, or you can ng generate library, first library, and then everything will be scaffolded for you. And that makes it pretty neat when you want to separate your code and architecture your Angular application or applications, no matter how big that whole thing grows in the end, right? So this is how it looks then. You have that project folder and you have your first lib and first app, and then you can maintain it better, and you see, okay, this workspace consists of maybe a library and maybe sample projects. This is what we have in an authentication library. So we have like the library code and then several sample projects where we have different flows and just trying to test everything, and it relies on that specific code, and you have like one sort of dependencies and don't have a mixture there and a mess there basically. If you want to go one step further, I would really, really recommend you to go to the nx.dev, which is a pretty cool workspace thing and a lot more. We'll lose a few words about that because they are doing a pretty good job and getting what we have just seen with a workspace one step further, because what they're providing you is a workspace which is separated in apps and libs in the first place. So they're doing this apps and libs separation, and they're providing you with the latest tool set and everything already set up that you can easily add libraries and easily add apps and connect them between each other, right? And this is also the point where I would like to mention that libraries in Angular are not only used to share codes between apps. What we also do in Angular is we call them app libraries, or at least I call them like that. So we have app libraries where we just want to separate code which is used from one app and one app only, and maybe it's used by another app. I don't know, maybe in the future. So keep in mind it should be like really decoupled, but it's only used from that. In that point in time, it's only used from one application, and we can name it, right? And so it can be like all your container components or your presentation components, which get into that library and only getting used by one application. So it does not, it's not shared at that point of time, but it may in the future. But those app libraries are a pretty neat feature and a pretty neat tool to separate your code, and you can see what your basically application, which relies on that library, does and what it consists of basically. What the Angular, what the NX team is giving you is caching in addition. So when you're running the commands like testing and linting and stuff, they're just caching the results, and they are letting the commands only run on files you changed in your branch, basically. So we are using that in a project, and we are really satisfied because it's really fast when you're letting run all the tests on your local client, and it just like caches any library I didn't touch, and all the libraries or apps I touched, it just lets the tests run or the linting run or whatever you would like to run. Another nice thing is the dependency graph, which get automatically created for you. And I have a screenshot here from a YouTube video those guys have. And you can exactly see, okay, my application is relying with a lazy loading on that library, or it just eager loaded that library. And here you can really control which library is used by which application. So visually, so you see it as an architect, you see if like a file, if a an arrow goes up, which is most likely wrong, it shall go down and stuff like that. So you have an overview of your complete workspace, and you see, okay, this library uses this library and this app uses this library, but it shouldn't, and stuff like that. You also see when it's got lazy loaded and when it's got eager loaded. I found pretty much bugs basically in my applications when I just let this thing run. And you can easily migrate from the Angular CLI to NX Workspace. So this is pretty cool. You can also define dependency rules, which is kind of like an architecture guide. He's just snaking through the application and says, hey, if you import that library, you shouldn't do that. So you have like a depth constraints, and you have an app which is called like M2 solution, and it just only depends on libs with tags like logging, notification, UI data, and stuff like that, right? So you can really, really control which library this application should rely on. And if you do a mistake, it will spit out an error and linting, right? And what they also do for you, last but not least, is the latest tool set, right? So they're giving you Cypress tests if you want to. They're giving you like Jest instead of Karma and all that kind of stuff. So everything is set up for you. I would really, really give that a go. And before we come to the end of the presentation, if you want to know more about Angular libraries, I would like to refer you to a Pluralsight course, which was done by a pretty cool guy. And yeah, maybe you can give that a spin, and maybe you can get more into Angular libraries and how you can separate code and organize the code in your applications. This is the link, and I have also the QR code. You will get the slides, I think, afterwards. And yeah, that's basically it. And that's basically my talk to architecting Angular apps with libraries. But before we really, really end this talk, I would like to refer to that one slide we had at the beginning, right? This don't repeat yourself slide. I would like to give you on the way that sometimes the do repeat yourself is a little bit better. So if you have like one function which you like to duplicate because you want to deliver like a feature, sometimes it's better just to copy paste it and move on, deliver the features, right? Because that is what we want to do. So do repeat yourself with caution. Maybe the third time you could extract something, and always think of delivering the new features, because that is what we want to. And in the end, I can just say, thank you very much. Stay sane and please take care. And these are my contact details. So if you want to get in touch, these are the data. And yeah, I would like to hear from you. Thank you very much.
Thank you so much, Fabian. Wow, it was amazing presentation.
Thank you.
A lot of information. I really love this idea about the libraries and how Angular deal with it. So yeah, I love it. Thank you so much.
Thank you for having me.
And next in line is Orestes Caratedo. Can you hear me?
Yeah, that was pretty close.
That was close, yeah. Thank you so much. Okay, the stage is yours.
Thank you for having me. Thank you, Darius. Thank you for inviting me. It's been great, great talk so far. I think the schedule works out pretty well because you had like one presentation was mostly slides. Now you had like the really cool live coding from Eliran. Again, cool presentation. And now we're going to go back into live coding. So that's what we're going to be doing. And I'm going to be talking about Scully, which is the static site generator that we recently have as of, over a year ago or so. It's still in alpha, but it's a really cool tool. And I think, if you're interested in Angular, you're probably interested in this tool. So the source code for everything I'm going to be talking is right here on my GitHub. It's right here, the first pin. It's everything I do. Most of my presentations are open source, so you're welcome to just fork away and play with it. I'm going to be using some branches to go through the different steps, so you can follow that too if you want to. And well, I'm a software engineer. I work remotely for a US startup. We do software consulting, and one of the products that we do is a security company called Navigo. I work from Barcelona right now, if you can tell by the cool, Sim City-like background that I have. So yeah, let's get right into it. So I built this demo project, which is a Pokemon browser. And I'm not a person that has a lot into Pokemon, so I just built this, let's explore this. Let's see what we have. And I'm going to be using this project to illustrate what pre-rendering and static rendering helps with, the issue that we have with the life cycle for our web applications. So you can see there's a list here of 10 different Pokemon, and basically what the project does is just shows you the list, and if you click on one, it takes you to a URL that is specific to that Pokemon. Since their names are unique, that's basically their ID, and it shows you the little picture and a couple of details. I'm not super into it, so you know, this is helpful reference if I ever need to remember anything about a Pokemon. This is built using public data that's provided by this API, which is pretty cool. It's called Poke API. You don't need to sign up for an API key or anything like that. So if you're doing demos often, or if you're using, you know, other APIs, those sometimes they need some setup. And I find when you're coding with somebody else and you just want some easy data, this really works well. So let's see. This is an app that's built with Angular. We're gonna go into the code in a second, and what I'm gonna do is I'm going to show you what it looks like when you load this page for the first time, and you're not in the, you know, best network speed top tier. Like right now, I'm on a 1 gigabit per second fiber optic to the home. Not everybody has that. When you're on your phone, you probably, you know, you don't have like the best 5G. We're not there yet. So what I'm gonna do is I'm gonna pretend this is the first time I'm visiting this page, and you can do that by disabling the cache right here. That'll mean that every asset that this page references, it needs to be downloaded because there's no caching. And there's something else that I'm gonna be doing. There's this throttling tool right here. I'm gonna bump that up so you can see it. There's this throttling tool right here in the developer tools. I'm gonna use fast to see how fast that is. So I'm gonna reload everything, and we're gonna watch together what the user experience is when you load this for the first time and you're on a fast 3G network. So you can see everything's blank to get started. You know, that's not a great user experience. You can see a gigantic file that's getting downloaded here. Yeah, that takes a while. This is not the best use case. Is there anything that we can do here? Oh, there you go. You saw that the list was loading. There was like a little message, loading list, and now we see everything has been loaded. You can see just by inspecting the network panel, you can see the requests that were happening right here, and you can see the point where I was getting the list from the actual Poke API. You see that waterfall effect. You need to wait for the previous scripts to be downloaded and then executed, be interpreted for your Angular application to then actually make the call to the API. So there's a ton of stuff that needs to happen for something that is ultimately static, right? It's not like this list of Pokemon is going to change every day or every minute. I guess every once in a while they add a bunch more. But there's no really a good reason for this page to be fully dynamic. There's no user interaction. So this is a great candidate for using Scully, which is a static site generator. So this is the repository for Scully. It was built by some people that are probably very known in the Angular community already. It's been out for some time. It's still in alpha, if I'm not mistaken. Now is when, you know, I find out that they released the public version. No, it's still in alpha. So, you know, everything you do, you need to be kind of cautious. But for a project in alpha, it's really, really good. And you can already do a ton of really interesting stuff. So let's go into the code and let's figure out how Scully works and what we can do, to our project to improve the performance. So first of all, you know, this is the source code for the application. Let's just go into the application module, and I'm using routing modules, just like most people. You can see everything is sort of coming from this Pokemon module. This Pokemon module has its own routing module, and there's only these two views, these two components. If we go to the list component, you can see right here I have an observable, which is what I'm using on the template part of this component. and this is just coming from the service. It is just an HTTP GET for the API because you don't need any keys. It is pretty straightforward. So that is the path that we're going to be following. How can we turn this into something that is static? So if you go to the DOM panel, the elements panel here, and if you expand everything, or if you just go here and do, edit as HTML, you could just copy all of this code. And actually, you should probably do it for the entire HTML file, but you can just copy all of this code, paste it in a separate file, a static HTML file. And as long as the references that you're making here, the Angular has generated for you, as long as those files are served besides that static file, this is going to work just the same. The way Angular works is when it loads, when the script gets downloaded and executed, just like we saw here. So, for example, if we show the entire timeline, you can see how it's unloading the different parts that Angular is generating. This is in develop mode when I'm using the local server, and only this bit is the part that I've written. This is the part that is just my application. This huge file, for example, is basically everything that you have in Node modules that you're making a reference to. And yes, when you build your Angular application for production, this file, it gets optimized away. The download size is a lot smaller, but there's an argument for, do you even need this? So when Angular loads, if the HTML structure is already there, if all those elements that you need are already there, due to the way that Angular does the diffing and does the checks on the DOM, Angular is not going to touch anything if the state is already what it needs to do. So basically, that is what Scully does. Scully goes through your project. It figures out all the URLs that it needs to visit. It opens a server in the background, and it opens a headless browser and just goes URL by URL, visiting all of them, taking a snapshot of the DOM at that point, and it just saves it as a static file, which is pretty genius, and it works pretty well. So what we're going to be doing is, first of all, if you're following on GitHub, I'm on the step 0. I'm just gonna go and install here Scully. So I'm actually just gonna search for the command because I've done this like 1,000 different times. If you want to know how you do it, you basically go through the documentation. It is pretty easy. It is pretty well documented, but it's going to tell you to do exactly this thing. Just run NgAdd, which is going to be using the schematic from the package to optimize your project, install the dependencies, and inject a couple of lines of code in your application. It's probably going to take a couple of seconds, even though everything has been downloaded already. It's probably updated into the latest version now that I think about it. I'm gonna cross my fingers and hope nothing breaks as soon as I say that. Well, it doesn't matter because I already have this installed, so let's pretend that doesn't happen. I'm just gonna check out to the next step where this is. This has already been installed, and I'm going to show you what Scully does when it doesn't break. It's probably about something about the next version. So basically, Scully is going to inject itself here, and what it's going to do is, this is the part of Scully that is going to look at your routes, and is going to figure out which routes you have defined in your project. And also, it's going to inject itself in your package.json. It's going to add a couple of scripts right here. Maybe it didn't add them, but we can just run it. It'll work just the same. So yarn run Scully, and out of the box, without doing anything other than just running that command. Well, Scully is complaining because before running Scully, you have to run a build of your project. So fair enough, let's run that. It'll take a second. But out of the box without touching anything, just by running ng-add scully.io/init. And those couple of lines, they get added and your project is just ready to run Scully. Let's give it a second to build. It looks like I didn't pray hard enough to the demo gods before this, but hopefully it'll work out. In the meantime, I'm reading the chat if, you know, if anything goes wrong, if you want to ask anything away, I'm going to be reading that. So let's run Scully again. Okay, Scully is starting a server in the background. Okay, there's a warning in there about one of the routes that it couldn't deal with, but you can see that it generated 2 files, and we can go into the source code and see what's in there. So right here, besides this is the name of the project. So this is what it gets generated by Angular. You're already familiar with this. This is what was generated by Scully. And it looks pretty familiar, but there's a difference, which is there's this file right here. If you remember on our routing, everything on the /URL was redirected to /Pokemon. So now you have this index.html, which is what we just talked about. It's just a direct snapshot of the DOM. It's just copied and pasted. It's making reference to the same files. And like I said, if you were to serve this on a simple HTTP server, this will already work, and it will save you. It will save your user that long blank screen that they were staring at the beginning. So that is already like a really, really big improvement. There's a couple more things that Scully can do. For example, there's this specific route for, hey, you have 10 Pokemons. There's going to be 10 different URLs because there's going to be 10 different IDs. And Scully is detecting that this route has a parameter, which is ID, and it doesn't know what to do with it. It's like, hey, I don't know, you gotta teach me how to deal with these kinds of URLs. So like I said, the documentation is pretty good for a project at this stage, really. And there's a link, everything is linked in the repository in GitHub to this part of the documentation, which is teaching you how to write a plugin that teaches Scully how to deal with these URLs. Basically, the way it works is you can build a plugin, and I'm just going to check out to the next step to teach you what it looks like. So when you run that initial command, Scully also adds a configuration file, which I cannot see right now. Oh yeah, right here. And out of the box, it detected what it needs to output your static files. It just uses static. This is the regular file where your Angular application gets built to. It detected the name of the project, and here is where you can pass specific configuration for different files. So in order for you not to have to, suffer through me waiting for me to type everything, I'm just gonna check out to the next step. And we're gonna see magically this configuration is gonna change. So let's pay attention to the part below before I explain you what's going on at the top. So the important part is this. This is a route definition for Scully. And basically anything you put in the value for this key is going to be used as the configuration for that route. So if you have anything that you want to pass to the code that you're going to be writing that handles those kinds of URLs, in my case, I want the URL for where I'm going to be getting the Pokemon from. You can put it here. I could have just hard-coded it somewhere else, but I thought it was nice to have it as a configuration function. So the way it works is Scully gives you a couple of different functions to do this kind of thing. You have the register plugin, which is used to register a plugin. And a plugin is just an async. It's a promise function that you can use. And that allows you to do all kinds of cool stuff in there. What you need to return is route configuration. and it'll wait for your code to run. So you can do stuff like, I'm using this helper that comes also from Scully, which gets me the JSON response from an HTTP request. And you can see here, this plugin configuration is this object that I was mentioning right here. So I have access to this URL. If I wanted, I could be using that list of Pokemon from, a different server. There's other methods that you can use for using static files and local servers. There's a bunch of helpers that Scully has built in. So in my case, I'm just getting the list of Pokemon, and then I'm using this other helper, which is route split. And this is going to give you the pieces of the URL that you can use to replace your ID. So basically, this gives me a function. That function, I only need to pass the ID, what you want to use for the ID in that path, and that is going to be doing the replacement. I don't need to know what's the name of the argument. If I have multiple arguments, I can pass multiple values here. It makes it really, really easy for you to write something that is going to get the list of all of those IDs that you want, and with that, create all of those URLs. So then you only have to call the register plugin. I'm just using this variable here, so I don't have to type the name twice. This is just a string. And this is the kind of thing where you type it twice, and in one of the places you lowercase it or you uppercase it, and it doesn't really work. So just extract that to a variable. That is going to be easier. And if we go to the console now, and we don't need to run the build again because we haven't changed any of the source code in our application, we can just run Scully again. The only thing that has changed is the configuration. Okay, this warning is just because it's using HTTPS to connect to the API. And now you can see that Scully knows about all of these different IDs that it didn't know before. And if you go to the distribution directory, if you go into static, now inside of Pokemon, you have view and all of these different URLs. And if you go here, for example, this specific Pokemon, and let's format this so you can see it. You can see that the actual Pokemon name is here, and the actual image is referenced, whatever it is referenced. I can't find it right now. Oh, right here. And the text is here. So all the information was loaded by the browser by the time that Scully took that snapshot. And you can use this to turn something like a dynamic page like this one into something that by the time the user gets all the HTML and the first time the browser paints it, you already have all your content. So let's take a look at how it compares serving this static file versus serving the original Angular. So what I'm going to do for that is I have another step in here where I've installed a local browser, a local server, which is called HTTP stir, almost like hipster, but not quite. And basically this quick server, it serves HTTP over a specific port. It uses whatever directory you want, and it uses the push state. So if you're using HTML5 push state, which Angular uses, as you know, it's going to support that. So I'm just going to run this, and I'm going to run this one too. So we're going to have two more servers running. Remember, these are not Angular servers. These are just plain HTTP servers, one on port 333 with what Angular generates, and one on port 444 with what Scully shows us. So let's compare these 3333. This is the one generated by Angular. And if you look at the configuration, I think I'm even using, well, I'm using whatever I just built. So let's run a production build so we have a little bit of a more fair comparison. And let's run Scully again. So Scully picks up the scripts optimized for production as well. And this will be Angular optimized to the best of the abilities that Angular can do versus the static pages generated by Scully. I'm just gonna run Scully again right after this one is done. Okay. And again, it is pretty fast, considering everything that it does in the background. And the first time you run it is going to take a little bit longer because it has to download well the actual headless browser that it uses. Okay, so 3.3.3.3. This is the version of Angular that was optimized for production. And you can see I'm still disabling the cache. I'm still on fast 3G, but now everything loads in like 3.52 seconds. That, you know, that is a lot better than the 10 seconds that we had before. That's fine. And, you know, debugging like this or just checking the user experience like this, you know, that's okay, but we can do better. There's this profile that you can use in Chrome that can take screenshots for you. There's one little caveat with this, which is that it doesn't really clean up the page before it does what it needs to do. So I'm just gonna change here the background to red. So you can tell when the profiler that we're gonna be running right now, when it starts profiling, the first couple of screenshots that it takes, they're actually coming from the previous view that was in the window. So that can throw you off when you're debugging a little bit. You can see for the first, you know, couple of seconds, Chrome didn't paint anything because it wasn't ready. You can see here, you have to open this network section in the profiler, and you can see how it needs to still, this is, remember, this is the Angular build part of the code. It was built for production. You go through the downloading, parsing, and executing of this, and only when this is done, you can see the first hint of something happening in the page, which is rendering that first outermost component, and you can see then the rest of the life cycle. Now you can see the loading text and the actual list, and if you check right here between the loading text and the actual list, you can see the call going out to the API. So this is a pretty useful tool to make, you know, sensible decisions about what your code is doing. Let me open now the version on port 4444, which is the one that was generated by Scully. I don't know if you picked up on that, but that was pretty fast. That took no time. Let me make sure that we're on equal conditions. So this is on a fast 3G network, disabling the cache. Let me run this again. Yeah, I didn't see any blank space at all. Then you saw for a second there the loading indicator. It took like 3 seconds to load. I think the other one, it took like a couple more seconds. So time-wise is already better. But if we check the experience, let's go to the profiler and let's do the same thing. Let's just remove everything here. And let's set the background to red so we don't get tricked into thinking that we were painting before it was actually painting. Let's run the profiler again. And we're going to see the experience is much different. There's a little bit of a gotcha moment there that we have to talk about. So here you can see the very first time Chrome paints anything, it's the entire page. There's no waiting for the network. There's nothing. This is the best user experience you can have. As soon as the HTML is downloaded, the browser can render that, and the user sees no blank page. There's a gotcha moment here because if you see after the scripts have been downloaded, parsed, and executed, you can see the API request going out again, and you can see that the list reverts to the loading state again. You know, that's what's happening. Angular doesn't know that the HTML already has the entire list because the way I wrote the code is not checking if it was loaded again. Basically, I didn't save it to the state. There's ways to do transfer state when you do pre-rendering with Angular, but in our case, we can do something even better. Because if you think about it, you don't even need Angular at this point. Like, these are just regular links. You can navigate these through regular links. You also saw the loading screen right there. If I reload real quick right now, you can see that it's going to do the same thing again. It gets the initial HTML, it renders everything, but then it needs to go and check with the API and repaint it. But there's something that we can do. We can write a plugin for Scully. So when we generate the static HTML, it just goes here to the end where all the scripts that were generated by Angular are, and just removes them entirely from our code. And it does that for every page. There's a link to an article by Sam. I'm not gonna try to pronounce his last name, but it's pretty good. It goes a little bit into the in depth about plugins for Scully and how to write one of them. Again, that is here on the links at the bottom. I don't want to go over time, but I think this is a pretty good argument for why it is better to generate static sites for things that are static instead of having to download, parse, and execute all of those scripts when you don't really need them. I'm going to stay for the questions, and if you have any, just shout them out in the chat. Thank you for having me, Darius. Back to you.
Okay, thank you so much for a great demo. Yeah, it's really, really interesting, very promising project, I think. And first question, do you have any experience with SIO and Scully?
Yes,
especially with some dynamic content, or something like CMS generated, yeah.
The way I got into Scully was precisely because I wanted to do, those open graph tags that you need to have to look good on Facebook, Twitter, and all those places that check to your metadata. I needed to do that. And if you have dynamic content like this, you can use the service for Angular to inject tags in the head, and you can inject those tags, and that's fine. But that is not going to show up when the crawler or hits your HTTP servers. You're going to get a blank page where everything needs to be rendered. So Scully was the tool that I used to add those tags dynamically. I even used like a route guard to do that. So even before anything was rendered, those tags were already in the header, and I used that to generate those. So I'm assuming most of SEO issues that we have that are sort of like that can be solved by just having a static site.
Perfect. Thank you. Okay, one more time. Thank you so much for this great demo. And now is the time for the Q&A session. So if anybody have some question, just write this question in our YouTube chat. And do we have any questions for now? No. We don't have any question. So, guys.
Eleron had a question, no? Eleron, did you have a question?
Okay. So thank you so much. It was great to see you today. And yeah, I hope we see soon on NG Poland or JS Poland on both conferences. We organize it this year in the hybrid system. So some people can be on this conference in person. Some people can just watch the conference on the live stream of the conference. Yeah, so one more time, guys, thank you so much. And I hope to see you soon.
Thank you, Darius.
Thank you very much. Thanks for having us and for organizing.
Bye-bye.
Thanks a lot.
Thank you,
Bye, everyone.
Bye-bye.